I have received two papers from your side, one for physics and the other one for chemistry.
Oh, yes. Oh, that was like, remember the test that I was telling you about, like before half term?
Okay. So
Yeah,
those,
it was quite a long time ago. But I got my scores back and I got a grade 9 in both of them.
yeah. Even I had a look that on the front sheet of one of the paper, you have noted down 25 as targeted marks and you have achieved 33, I think, or
Yeah.
32 in that. So why you
Yeah.
were feeling that low with your, like, why your expectations were
Because
that
I
low?
don't I don't like getting my expectations too high, so I don't get disappointed.
Okay, so and if I ask you, were you like seriously thinking about 25 or you had something else in your mind and you were writing something else on the targeted?
No, I actually had like 25 in my mind. Like it seems okay, you know? It's not too high and it's not too low.
Okay, and when you get the answer, like when you
I
get the
was
score,
so happy. I was so happy.
okay, well, yeah, your paper was nicely attempted. I received it like not really long ago, but yeah, in a very short time, but I had a look at all the papers and everything is well attempted. Yeah. There were a few questions. One of the question was like the mistake was so silly that I was not expecting it from you.
Which one?
That was in chemistry, and the question was on isotopes.
I don't remember.
Okay, wait a minute. I have noted down that thing. Yeah, it was on page number 5. I think it's C. Oh, actually, I'm not able to figure out my own writing today.
Oh!
Is it the impact of company?
I did not influence you, definitely.
No, it's you.
No, it's not.
Okay, that's actually I have noted down things with this pencil, but not a pen. And for me, it seems like it's this question, page number 5 of chemistry. It's question C, first part, where they ask you about like there isn't two elements, there are two isotopes, and they asked you about like which particle is going to differ in those isotopes. And I don't know what exactly you have mentioned. You have discussed about somewhere about weights or number, I don't know. But there you
I
need to
don't.
mention the number of protons and neutrons. Yeah, the
Okay.
answer was that they both contain same number of protons. What they lack is that they have different number of neutrons. So that was the answer required by the question. And you had noted down something else related to weight and mass. I don't know what was that.
Okay.
Yeah. If we talk about the other else, yeah, the other paper is well attempted. But yeah, there were a few questions which you haven't, like the answer was wrong from your side. Well, I have noted down the things for those questions. I'll discuss them if I got time today. Or otherwise, we can keep, yeah, I haven't received a worksheet from your side. I'm done with that.
The
The one
physics
on
one?
waves.
Oh, the waves.
Yes, the wave.
Uh, I don't think I have. I think I've like gone through half of it, but then I had to stop for some reason. I don't know. I'll look for it after the lesson.
Like, have you attempted that? Like, have you tried to do
Yeah,
it?
yeah. I've finished like I think half of it.
Okay. So, with the question okay, or you're finding difficulty in doing the questions as
Yeah,
well?
so far it was okay, but like there was one question. I remember it was like something about like measuring what the wavelength is, but they didn't give us one of the like things.
You can
So
skip.
I did,
Okay. Yeah, it's been
yeah,
a
I
long
don't
time.
remember it, but like I'll send
You
it to
can,
you.
yeah, you can do one thing. You can skip that question and you can try to do the other one.
Yeah,
Yeah, because it's been a long time. I have sent it to you. So yeah,
yeah,
send it to me as soon as you're done with that. Skip questions which you're not able to do. I'll discuss it with you. And the that worksheet and the questions from the your test paper, like I have received because I have received a message that I need to discuss the question with you. And even I was thinking, like, the question you haven't attempted in the right way, I need to tell you the answer, what exactly you need to write down. So we can have a discussion on all the questions, and I'll bring some more questions, and we can have a separate session. I mean, on the next Sunday, we can discuss everything. Okay.
Okay.
Yeah, until Sunday, you have enough of time that you can do all the worksheets if you're left with
Oh,
any of the questions.
it's just the waves one.
I mean, yeah, I'm talking about the number, like all the
Yeah.
papers of a waves.
Okay.
Yeah, if you want more, I can send you more.
Can
If
I
you like, if you have
have
a free
one
time,
for the bacteria?
okay, you want questions for bacteria. Okay, I'll find it out and
Yeah.
I'll send it to you.
But it doesn't have to be like a whole test. I just want like some a few worksheets just for like the bacteria topic because I'm scared I'm gonna forget because it's all
Okay.
new information and like it's so confusing.
Okay, I'll do one thing. I'll give me a time for 1.5 day or approx 2 days. I'll write down the question with my hand. Okay, then it won't
Okay.
be that lengthy. Yeah, I'll write down the questions on a sheet of paper, then I'll take a photo and I'll send it to you.
Okay.
At least you get enough of confidence because I have noted down all the questions by my hand. So I won't be writing a very big questions and also a very big list of questions, definitely. And
Okay.
yeah, and you'll also get motivated because I have noted down with my writing, so you'll try to
Yeah.
write it down. Yeah, one more thing I want to mention. What happens to your writing an exam? Yeah, especially in the longer question. I mean, as soon as I received all the sheets, okay, and then I started looking at them. I thought, okay, I'll go through them once I'll get it there. Like, I closed them as soon as I saw the writing. Okay, I
Oh
closed them.
no.
Okay, I'll take my free time and then I'll go through all these things. Again, I open everything. I read all the short answers, and then when it come on, like reading out the questions, the bigger one, again I close the sheets. It took me 3 attempts to like get a courage to read out the answer of the longer question.
It's because I don't have time. In the exam, I don't have time for neat handwriting. I just have to note down everything. I remember, especially in the last question, I think it was like 6 marks or 5 marks. And I had 5 minutes left for it. And my head was blank. I had nothing in my head. So I literally just wrote down everything that came to mind, and it was so bad.
Okay. I think the way I was like, building up my courage to have a look at your answer sheet, maybe your teachers were doing, or do you have some more friends like you, like the one who write like this, like the doctor
I'm
handwriting?
I'm the messiest one.
Okay, it's okay. We'll work on it together. Or otherwise, I have to come over there to work on cursive writings.
Okay. Or I can just not write in cursive anymore.
Yeah, I just want a simple handwriting. That's it. I'm not asking you to write in
Yeah.
cursive.
I don't know. It's become like such like my hand just does it. It just joins the
I can
letters
see
together.
that thing in your writing.
Yeah.
In the beginning of the paper, it was fine. Yeah, it was fine. But as soon as I was turning on to the bigger question,
Yeah.
that needs courage.
Yeah.
Okay. Otherwise, I think the next time I'm going to get a paper from your side in this handwriting, I'll come up over there personally. I'll
Okay.
leave all the sessions and I'm going to come there. Yeah.
We should
Okay.
have separate lessons just for handwriting.
Yeah. And I'll be there with you for the 24 hours. Just imagine.
Oh no, okay.
Yeah. Okay. Let's talk about this. Yeah. Why did all the basics of microscopes, the uses, the instrumentation, like what all parts it contains? I hope there is no problem from there. Is this clear, right?
Yeah.
Let's talk about the types of microscopes. Well, you need not to do things in that detail, which I'm going to tell you, but I'm just going to tell you so that you can at least, because I think in the starting, you were quite excited to know about like which microscope we use for which purpose. Okay. So that's the reason I'm going to tell you about all. Otherwise, till your level, it's enough if you just do about simple compound, a little bit of electron, that's it.
Okay.
Yeah, that's enough for you. Otherwise, if we look at the types of microscope, we have basically 5 types. There is one more which I have like included in the images, but not over here. So one is a simple microscope, which you can see in your labs. It's very common. Okay. Then is a
Yeah.
compound microscope. Like once you people get a kind of responsible one, there you get this compound microscope. Till you are naughty, and for you people, the microscope is just a toy. At that level, they're only going to give you the simple microscopes. But once it seems like, okay, you people are quite of sincere. You seriously want to see something from biology. There, they're going to give you the compound microscope. And yeah, for electron and for other scanning probe microscope, you people have to be super serious because they are only available in bigger labs, not at school level.
Mhm.
Okay, they are only available at bigger lab like forensic labs or the NRI and stuff like that, like the big immunological labs and virological labs.
Yeah.
Are you done with the names?
Yeah.
Okay. Okay. This is how your simple microscopes looks like. Okay. So if we look at the simple microscope, the difference is that it only contains a single lens. Okay. It is consists of only single lens, and the magnification of this microscope depends on that single lens only. It contains, can you tell me the 10 elements name from periodic table? Yeah.
Hydrogen, hydrogen, helium, lithium, beryllium, boron, nitrogen, oxygen, uh,
Where's the carbon?
oxygen. Sorry.
Where's the carbon?
Uh, oh yeah. No. So boron, then carbon, then nitrogen, then oxygen,
And
then
you messed up all.
oh,
Try to tell me the names from beginning again. Yeah.
hydrogen, helium,
Helium, lithium,
lithium, boron,
beryllium, then
beryllium, then boron, then nitrogen, then oxygen, then carbon, then fluorine. Oh,
it's okay. Hydrogen, helium, lithium, beryllium, boron, carbon,
okay.
nitrogen, oxygen, fluorine,
Carbon, nitrogen,
neon.
oxygen, fluorine, neon, magnesium. No, potassium, then magnesium, right? Or is it sodium? I'm so confused. Sodium, then magnesium.
Do you have a periodic table in front of you?
No.
You were supposed to paste a periodic table in front of you so that whenever you're going to take any class, definitely once in a day at least you will have a look at the periodic table.
Okay.
Yeah. So print it out and paste it in front of you.
Okay.
Yes. See, it could be a random checking, like are you able to remember the things or not?
Yes.
Okay. So in simple microscope, we have only one single lens that is used for magnification of the sample. In the previous session, I told you 2 terms. That's one is magnification and another one is,
Um, re. Wait, I know it.
okay, you know that.
Resolution.
Yeah. So what's the difference between magnification and resolution?
Magnification is used to like expand the image, and resolution is used to like make the image clear.
I think you're going to give me the statement with the use of your hands. Okay, I'll interpret it. Okay. So magnification is the one which helps in enlarging the image of any sample, and your resolution is the one who like makes the more clear image, the one which makes
Yeah.
the more clear image of anything. Okay. That's what, like whenever we talk about the cameras of mobile phones, we talk in resolutions. Like my camera of the phone is that megapixel resolution, right? We never say
Yeah.
it have a magnification of this much. No. Always what we mention is the resolution of a camera. That means the
Yeah.
clarity of a camera. Okay. So can you tell me which kind of camera, like the lens we have in this simple microscope? Is it a convex or a concave?
A convex.
Yeah. So the one lens present in it is a convex lens. Okay.
Yeah.
So if we talk about the application, I mean, you don't have to go in detail, that's enough. Like, where do we use simple microscope? So if we look at the use of it, we can write down one or two use of it. So the one use is it is very common among the watchmakers. Because if you look at the like the parts of a watch, they're really small, so it's very common. Okay. The next is jewelers. Because
So
if you look,
basically, it's used for like all everyday stuff.
yeah, it's a common one and several, it's not that expensive even. And neither it have a very much magnification and resolution. So it's basically used by the very common peoples and at school levels. And your favorite, sorry, not, that's a dentist. Also by the dermatologists.
Isn't dermatologist for like skin?
Yeah, derma stands for skin. So just to identify, like, as you can see, all the fungal diseases, like, and all the skin problems, they looks like same, right?
Almost.
Like whenever, like either if we have a fungal disease or it's a bacterial infection, what all we can see is okay, it's a rash, it's a red color rash. That's it. This is how we
Mm-hmm.
identify. But
Yeah.
the structure is going to matter a lot to a dermatologist. Like they are going to need the structure. How exa Is there any cat behind you?
Yes. It's Leo.
And that's a different one, right?
No, it's the same one. It's Leo. He's sleeping.
That one was that one was white in color, I think.
Leo?
Do you have two?
No.
I
I'm so
thought I
confused.
remember that. Yeah, I thought the cat which I have seen with you is white in color.
No, I don't
And the
have a
right,
white cat.
okay,
He's
maybe.
ginger.
So it may be possible I would have seen a cat with some other of my student. Yeah.
Yeah.
Okay. Let's come back to yeah. So what they do is they use the simple microscope to analyze the structure of the disease which we have on skin, and then there they decide like which infection it is. Because for us, every fungal infection, every bacterial infection is just as rash, we can say. But for them, it matters like how exactly it is. So there we use simple microscopes. Then comes the compound microscope. So compound microscope is the one, it's a quite advanced form of simple microscope. Everything is same in this. The thing which is going to matter, like going to differ is the number of lenses present in it. So there we have more than one lens. So the magnification of the microscope depends on the combination of like lenses. Okay.
Mm-hmm.
So this is where from this portion you're going to have a view at it. And there is one lens, and also there are number of lenses which helps you to visualize. So magnification is given by a formula. Well, I don't think so. We need to do that. Okay, so magnification will be the combined result of this one and these lenses present over here. There is your mirror. From here, either you can have a source of light to be as a halogen bulb, or it could be a just sunlight. That depends. That all the forms of like microscopes, either they can have a halogen or one. They all are compound, right? So just on the basis of the availability of the energy sources, you can't say that this one is compound and this one is something else. In just compound microscope, you can have the source as sunlight and as well as of that halogen lights or some other else things. Okay. Yeah. So can you tell me the application of compound microscope?
It's almost the same, but it has two more lenses. I like more than one lens.
Let's write down the principle. Well, that's not something different, but still. The compound microscope is that the combination of lenses enhances the magnification. Because if it comes on giving you the, like if they ask you the principle of compound microscope, there you need to write down this magnification of the sample. The sample is first viewed as a primary image in the tube and it is viewed again in the eyepiece. Okay. And I think we should also go for the principle of simple microscope. They can ask you that thing.
Okay.
Yeah. Yeah. A simple microscope is that when a sample is placed within the focus of the microscope, we get a virtual an erect, and a magnified image. Have you applied henna on your hands or it's a tattoo?
Hmm?
Have you applied henna on your hand or it's a tattoo?
Yeah, it's henna.
Okay.
Getting ready for Ramadan.
Okay.
Yeah.
So it means you know how to apply, like, are you expert in that?
Yeah, I have. Wait, I have a whole pencil case just for henna.
Like, are they of different colors, right?
They're like different shades of brown.
Okay.
Yeah, and then this one's just black.
Okay. So like you keep on doing this, like
Yeah, I love doing them.
on your hand or anybody else in, like,
Anyone,
depend.
I don't mind.
Anyone. Okay. So how much time do you take to make a, like, to do a full of hand?
I've never. So there's like certain designs that I don't like doing because like they're just too hard, and I don't like doing flower designs because they like a lot of the times they just don't look good. Like if I'm gonna do a
Okay.
flower design, I have to copy it off something. But
Like,
if I'm doing
just you do it by yourself, or do you follow some specific, like, I think in henna they have a specific Arabic or different patterns, right?
yeah, it depends on the pattern.
Like Arabic type
If
hennas and
it's like a pattern with flowers, then I have to copy it off like something. But I can make up something in my head if it's not flowers.
what if you draw a biology diagram in the hand of someone else?
No, thank you.
Okay, that's good.
Yeah.
Actually, what I do,
I went.
sometimes even I try to make it up. And what happens me like to me, when I look at the image in like on phone, there was so much of designs in a single hand, right? But
Yeah.
when I start drawing, I just ends up with drawing a single flower and my whole hand gets full on. Like I don't get space to draw the other things. It's just a single flower on all.
I have a very good tip for that. So you get pen, like any pen, and you draw on your hand first, like with the
Oh,
pen, and
yeah,
then you
that's
can
easy.
trace over it in henna.
Okay. Yeah,
Yeah.
that would be a nice idea.
It's really, really helpful.
I'll try to use it.
Okay.
Yeah. Well, actually, I just like it for 2 days, and then the next third day, like when it comes starts coming off, I don't like that thing. And
Yeah.
that's the reason I don't like to apply it.
Okay.
Yeah.
Just wear
So,
gloves.
okay. Can you tell me the applications of compound microscope? What could be the application of compound? It's quite more specific than the simple one.
The eyepiece, the nose piece, the the
I'm asking
base.
about the applications. Where could you use compound microscope?
Like
Yes.
seeing cells.
Yeah, that's right. We use for study of bacteria and viruses. There were a lot of voices.
Is it gone
Okay.
now?
Yeah. Okay. So, study of bacteria and viruses is possible with the help of compound microscope, though we can't get a very detailed image of viruses and bacteria, but still it is capable of giving us an image. The next one is we use this in forensic labs. Okay. Like in checking out the fingerprints and similarity between the fingerprints, there we use it.
Yeah.
And also, it is used in the field of metallurgy. The one which are involved in extraction of metals, there they use it to identify the metal.
Mm-hmm.
Okay. Now comes the more advanced microscope we have. That's electron microscope. Now you'll say, what is this?
That
No.
does not look like a microscope.
Well, that's a concept present inside the microscope. Okay, it's something from inside. This is how things looks like
Okay.
inside a microscope. Okay. So
Okay.
as you can see, they have so many number of lenses, these three, and then again, two projector lenses. And this is the stage where they place the, that specimen and source of light. These are the flow of electrons. Okay. This is how the electrons flow. See, electron microscope is the most advanced microscope and they works in vacuum, the first thing. They're not like other microscopes. You cannot operate them in an open space. They work in vacuum because they deals with the flow of electrons. The flow of electrons is going to make an image for you. So here, the source of illumination is never never a halogen bulb or stuff like that. The source of illumination in electron microscope is a beam of electrons. First of all, let me tell you, we have two types of electron microscope. The one is SEM. Damn, they're not the names of two brothers. This one stands for scanning electron microscope. This one stands for transmission electron microscopes. The source of illumination illumination is a beam of electron.
Yeah.
They forms image of really high resolution, okay, and a very magnified image.
Yeah.
Even you can magnify the image in nanometers. That's the speciality of electron microscope. You can't do this thing in the simple and the compound microscope. But in case of electron microscope, you can magnify the image even till nanometers.
Okay.
Yeah, so you can write down. Can you tell me how do we write nanometers?
Isn't it like P and then like a weird N?
I was talking about in numbers.
Oh, I don't know.
10 raised to the power minus 9.
Okay.
Okay. So basically, as I told you, like we use a beam of electron as illumination source. So for this, like in order to create a beam of electron, we use a metal that is a tungsten metal, which emits out the beam of electron. Okay. We
Okay.
use a tungsten metal which emits these electron. What happens is basically we give a very high voltage current to this tungsten metal. Okay. And as you know that if we're going to give a very high voltage current to a metal, so what is going to happen? The electron is going to get excited, right? This is what happens. Like,
Yeah. Yeah.
and they starts moving up, and in that way it starts creating a beam of electron. That beam of electron is magnified with the help of the lenses, as I shown you. There are so many lenses there. They're going to get magnified with the help of those lenses, and then they will reach the specimen over there. They will uh, they're going to strike on the specimen image and will create a kind of Xerox kind of paper. Okay, see, there is my specimen. So the one where the specimen is available, what is going to happen? The electrons will come, they will strike, and they will go back, right? But the space which
Yeah.
is free, where there is no specimen, the beam of ray will go as it is. It will go throughout this,
Okay.
right? So in this
Yeah.
way, the one which is going to come and is going to strike back off, these electrons helps in forming image.
Because they always bounce. Oh,
Yeah.
yeah.
And this is how we get a sheet over where you will get an image. Because from the rest of the area, the electrons will go as it is, like without reflected back. And the space from there will go reflected back, that will look darker in the image, right?
Okay.
Yeah. And even in that too, like if you have a look, some of the area will be like really thin. So from there, a slight electrons will try to go from there. So that will be
Yeah.
a lighter. Whereas those space which contains the bigger, maybe the bigger cell apparatus, they will won't allow even a single electron to pass through them. So that will form a different kind of image. So this is
Yeah.
how we get an image from electron microscope. Okay.
Yeah.
Okay. I need to write over here. Can you tell me the need of electron microscope?
Um. So for wait, would it be used in X-rays?
No. Why we are going to use
Mm,
X-rays here?
I don't know.
They use
I don't know.
tungsten
It's just
metal.
like the thing about the movement of electrons just reminds me of radiation. I don't know why.
And no, the only thing which we are going to use a tungsten metal, very high voltage current that is going to
Yeah.
excite the electrons from the tungsten metal. And then this tungsten metal is going to emit a lot of electrons from it. Those electrons will reach to your, to the specimen present on the stage. And some of the electrons will go as it is, and some of them will get reflect back. Those which will reflect back are going to give you the image of the specimen.
Hmm. Okay.
Okay. Yeah. The most application of this is seen in the not the labs, in the industries, in the
Mm-hmm.
quality control area of the industries. There they use this. Okay.
Okay.
Quality control. Then, as you can look at the other two, like the simple and the compound one, the microscope do not have any setup to take an image, right?
Mm-hmm.
There could be one way you can take image, that is by placing a phone's camera on the eyepiece, then by
Mm-hmm.
focusing it on, and then that's the only way you can get an image, right?
Yeah.
But that's not an authentic way. But if we talk about the electron microscope, there is a like there is an available thing in that microscope that we can use a kind of specialized camera, and that specialized
Okay.
camera is used to get electron micrograph.
Okay.
Okay, yeah. So what we can get is an electron micrograph, and this is used by lots of scholars, PhD scholars, during their, like, especially those who do it with the with the living organisms, okay? Those who deal with living
Mm-hmm.
organisms during their PhD scholar
Mm-hmm.
time. So they make a lot of use of it. Okay. Yeah. Also, you can do study of metals and crystals in detail with the help of electron microscope, because you could get an image of the internal structure of the crystals and the metal.
Yeah.
Stereo microscope. So, can you tell me, do you have any idea about this?
There's like two eyepieces there.
That is also present in compound microscope.
It's actually it's quite similar, but there's like a top lighting instead of the bottom, it's top.
Yeah. And instead of objective lenses, they have mentioned stereo head, right?
Yeah. Yeah.
The difference is that in a stereo microscope, you can get a 3D view of any specimen.
Oh.
We also call it as dissecting microscope. Okay. Till this point, I hope you would like get an idea where do we use which kind of microscope, right?
Yeah. Yeah.
And how do they work? So if you look at the application, can you tell me where could we see this?
Uh, stage plate.
Yeah, that's definitely, this is the place we are going to place a specimen. But what could be the application of stereo microscope?
I don't know.
Anywhere where we want to have a look at 3D image of anything. For example,
Okay.
let's say you can find the application of stereo microscope in um, museums
Yeah.
in order to analyze the structure of the maybe the historic coins we have. If you want to check, sometimes you can see this if you, the people, those who are really interested in collection of coins, what they do is They want to check out the difference between the coins, right? And sometimes the difference is so small that you can't look at it like with bare your eyes, naked
Mm-hmm.
eyes, right? So there, good, you can find the application.
Yeah.
Examination of historic coins. Okay. Then
Mm-hmm.
microsurgeries. And again, the crystals. Do you know on what basis do we determine the quality of a diamond?
Um, is it the amount of like carbon or something?
Yeah, that's right. That is about that. Have you ever seen a diamond jewelry?
No.
You haven't seen a diamond jewelry.
Oh, yes, yes.
Okay, I mean that's why I was like maybe it's
I
really
heard you say a damaged jewelry. I was so confused.
no diamond jewelry. Okay,
Yeah.
so you must have and have you ever paid attention to the amount, like cost of that jewelry?
Yeah.
Sometimes it happens like for example, there is a person who have a ring of a diamond and that contains a really big diamond and that cost not that much as a person having a smaller diamond in a jewelry that cost more.
Maybe because it was like there's the because you know, for example, like pure, because it's pure diamond. So like carat gold, the more carats there are, the more expensive because it's like
Exactly.
more pure.
So the purity of a diamond depends on its purity. I mean, yeah, the cost of a
Yeah.
diamond depends on its purity. And how do we determine that purity? I was even not that aware of the thing. I got to know it like when I once went to a shop. There he told me and he explained me that in diamond, if you look at them with the help of microscope, you can see a very small dot. Okay,
Mm-hmm.
this kind of dot, a very fine dots in diamond that is not visible with naked eyes. Like if
Yeah.
anybody in front of you can say, okay, this is diamond, you can if he say to a crystal as a diamond, you'll agree. But you'll get to know about it in a microscope. There you can analyze the more number of these dots are present on any diamond, that much is impure. So the diamond which have the least number of these dots, that is known as the purest diamond. And there you can find the application of stereo microscope in field of crystals and diamonds.
Yeah.
Okay. Then we have one more and the last one, scanning probe microscope.
Wait.
Yes,
What was? Oh, I wrote all the um electron microscope things in the scanning probe microscope things.
just
It's
change the
fine.
name.
Yeah.
The next one is the scanning probe microscope. Now you look at the diagram and will see how on which angle can you say it as a microscope.
What is that?
That's a microscope.
I don't see it. It looks so weird.
This is your sample.
Yeah.
This cantilever and the tip is a part of microscope. And this point is going to analyze the structure of the sample. Okay,
Okay.
that much is enough for you. You need not to go on laser and photodiodes and stuff like that. Okay, I'm just telling you what happens is the microscope operates this cantilever and tip on the surface of the surface of the sample, and there you'll get the detail, a very fine, even nanoscale detailed structure of the sample.
Mhm.
That is the speciality of scanning probe microscope. That It can scan in nanoscales level. Also, it's that fine that you can get to know about the properties of a specimen, like specific properties. It can tell you the specimen's properties, its reaction time, its behavior. Okay.
Yeah.
Well, the use of this scanning microscope is on the very bigger level. It's not available everywhere. Neither nor everybody is expertise to work on it. Okay. And we use it on a bigger level where we want to know how exactly the specimen is reacting to something, like any kind of stimulus in the environment. So there we use it.
Okay.
Okay.
Yeah.
And by this, we end with the types of microscope. So is there any doubt?
No.
I think now you can, the first two are the more important for you, like the simple one and the compound. Then
Yeah.
comes the electron. And the latter two are, I don't think so that you need to go for them. They are for the bigger level. You don't have to go for them. Also, you
Okay.
don't have to look at the, the diagram of the electron microscope. That's not for your level. What you need to know is the structure, working, principle, applications of simple and compound microscope.
Okay.
Okay.
Yeah.
Structure, parts, like that is known as instrumentation. Principle, what is the principle behind it, like how it works. And working, very first thing is name of anything, then its principle, then comes is instrumentation, working, and the last is the application.
Yes.
Okay. So is there any doubt from this?
Nope.
So that's it for this topic. Now you can tell me which topic you want me to do. Like if I think I'm definitely going to get your worksheet by the next class.
Mm-hmm.
So in the next session, we're going to discuss those things. But still, you can tell me a topic. Which
Should we
top?
do enzymes? Because then that would be all of biology finished for spring 2.
Wait, just let me have a look at it. Wait, we need to do magnification calculations.
Okay.
Yeah, we haven't done magnification calculations. Okay,
Okay.
I'll include this magnification calculation in along with the discussion of the questions. I think that will,
Okay.
yeah. I'll
Okay.
bring more questions because right now I don't have questions because I didn't check out it that I need to go for it.
Okay.
Okay. Then you want me to do enzymes, right?
Yes, please.
Okay. For that, I want you to remember all the enzymes involved in digestive system.
Okay.
Yeah. And then we will start with the enzymes. And then we will left with the topics in chemistry, right?
Yes.
Okay, decided. So send me the worksheet as soon as you're done with that. Yeah.
Yes. Okay.
And then we will start, like we will discuss also, uh, be ready with that worksheet and along with the papers you have received from your school. So we are going to discuss on that. First of all, we are going to do the magnification of the microscope and then we will do that thing. Okay.
Okay.
Yeah.
Yeah.
So that's all for today's session. I hope you
Thank
like the
you.
session. Now you can enjoy with your cat. Bye bye.
Thank you. Bye bye.
Take care.